Now, as I told, this lecture is complete revision of our protection. Okay, 20 candidates have joined. Okay, this lecture is complete revision. I will share all 1 to 20 PDFs. Okay, and we will discuss, because this is complete discussion session, and this I will upload on YouTube. Okay, so you have to respond. Okay, now I will share our first lecture. Okay, I will share our first lecture. I will share my screen. Now, what is visible to you? Is this visible to you? Write in chat box. Is this visible to you? Write in chat box. Okay. Now this is our first lecture, protective relaying fundamentals. Okay. You can ask me or you can interrupt me at any time. You can interrupt me at any time. Okay. Harshada, Rahul. Okay. Now this is our first lecture. You can ask me any doubt. Okay. I will abruptly call the names. I will randomly call out the names, and then they have to answer. Okay. Now this is our first lecture. In that we have seen occurrence of a fault, then functions of protective system, what are the different causes of fault. Okay. What are the different causes of fault, then why protection is applied, what is the need of protection, that we have seen in first lecture. Okay. In that we have seen zones of protection. Okay. Generator zone, low voltage switchgear zone, then transmission line zone, then high voltage zone, transformer zone, and then again transmission line zone and high voltage switchgear, and then here it will be the distribution zone. This is our generator protection. Okay. This is your low voltage switchgear protection. This is our power transformer protection, high voltage switchgear protection. Different zones we have, zones of protection we have covered in our first lecture. Here we have studied that each and every part of our system should be covered by these zones of protection. There should not be any blind spot. Okay. Then what is the requirement of protection system? What is in that requirement? In this requirement of protection system, we have seen or we have studied different qualities of a relay. Different qualities of the relay, or what you call the requirement of that relay, how that relay should operate, or what is the prerequisite for the protection system. Okay. What is the qualities of the relay? Okay. What are the characteristics we require in the relay? That sensitivity, selectivity, speed, discrimination, stability, reliability, dependability, and security. Okay. These are the different requirement of protection system that we have studied. Okay. Now in that we have seen unit protection and non-unit protection. Okay. So can you tell me which relay comes under unit protection? Anyone can reply in chat box. Which relay comes under unit protection? Reply in chat box. Or which is the unit protection scheme? Correct. Differential protection is the unit protection because their zone is defined. Correct. Poonam and Namrata, correct. Himanshu, correct. Okay. Now here we have seen. Next, local backup and a remote backup. Okay. Local backup is applied. Here we can have either another relay or another circuit breaker. A remote backup, in remote backup at the substation, we have either additional relay or additional circuit breaker. This is our local backup and remote backup. Remote backup is applied at, it is long distance, it is applied at somewhat distance. Okay, it is applied at, you can call it is applied at, it is provided at the substation. Okay. Tripping mechanism of the relay. This already we have seen. Circuit breaker relay will get signal from CT and PT and then it is given to the trip mechanism. Here we have auxiliary coil of the relay. Here we have tripping coil of the circuit breaker. This from signal from CT and PT is given to the relay. If relay finds that actuating our fault current or faulted element, faulted quantity is greater than the set value, it will give tripping signal. That means this contact get closed, auxiliary coil of the relay will energized and this will close this contact and trip coil of circuit breaker will energize. It will give tripping signal to the relay. This already we have seen. Okay, this is about your first lecture. Okay, now we'll see our second lecture. Okay, second. In that second lecture, we have seen different classifications of relay. What are the different classification of the relay according to the quantities? According to the quantities by which the relay operates, either it may be over current, over voltage, under frequency, over frequency, over fluxing, and power release. According to construction, attracted armature type and induction type. Okay. According to the number of sensing quantities, whether it can sense single input or it can sense multi-input. Okay. According to its function, according to its function in protective system, whether it may be main relay or it may be auxiliary relays. According to the component and devices used, according to the characteristics they adopt. Okay. Here in second lecture, we have seen all classification of relay and there what is the advantages of electromechanical relay, what is the disadvantages of electromechanical relay, evaluation of relay we have seen in second lecture. Okay. Then microprocessor based relay, then numerical relay. Okay. Then numerical relay. This numerical relay have numerous advantage over earlier relays so used nowadays. Okay. So we have seen in our last unit that already we have discussed in last lecture, numerical protection we are applying everywhere. Okay. So this numerical relay we are using everywhere. Okay. Now different types of electromechanical relay we have seen: hinge armature type, plunger type, attracted armature type, induction relay, induction disc relay, induction cup relay, balance beam relay. Then here we have covered our second lecture. Okay. Then in third lecture, we have seen attracted armature type relay. Okay. Balance in attracted, what is the principle of attracted armature type relay? How it works, that we have seen in our third lecture. Okay. In fourth lecture, we have seen induction relay. How induction relay works, that we have seen in our fourth lecture. Okay. Then in fifth lecture, we have seen, as we know, this protection scheme, there are three basic protection schemes: overcurrent protection, differential protection, and distance protection. First step of protection is, or initial step is, overcurrent protective scheme. Then differential protection and then distance. This is our, you can call it as a first step. Differential protection is second step, and distance protection, that means difficulty level increases from overcurrent protection scheme. This is simplest protection we apply everywhere in power system. Okay. Here we have seen different classification of overcurrent relay based on the characteristics: instantaneous overcurrent relay, definite time relay, inverse definite minimum time. We have seen its characteristics. Also, we have seen plug setting multiplier. In last lecture also we have seen we have plug setting two settings are given on the overcurrent relay, that is plug setting and time setting. Plug setting for overcurrent relay it is from 50% to 200% in steps of 25%, while time setting is from for earth fault relay it is from 10 to 90% in steps of 10%, while time setting dial have settings from 0.1, 0.2, 0.3, 0.4 up to 1. TMS is equal to 1. Manufacturer generally provide characteristics for TMS is equal to 1. This already we have seen and we have solved problem in this lecture. Okay. We have solved problem in this lecture. Regarding that problem is based on time setting multiplier and plug setting multiplier. Okay. Now next. This is in sixth lecture. We have seen current based relaying scheme, that means differential protection. It is the start of differential protection. Okay. Discrimination philosophy. Now this overcurrent protection scheme where we are applying current graded scheme and time in overcurrent protection. Either it will be current graded or time graded, because we have two settings, plug settings and time setting. So based on that plug setting we have current graded scheme. Based on that time setting we have time graded scheme that we have seen. Okay, in current graded scheme this remains constant. In time graded scheme time is graded. In current graded scheme we have instantaneous overcurrent relay as well as IDMT relay. The relay picks up depending upon the value of current. Okay, while in time graded scheme we have time graded and we are using only definite time relay, where the grading will start from the far end. At far end we have the relay which is have lowest setting and it increases toward the feeder end. Okay, this we have seen in our sixth lecture. Combination we are using, that is time graded scheme and current graded scheme. We are using combination of relay, that is time grading and current grading. Okay, this we have seen in our sixth lecture. In seventh lecture we have seen phase fault and earth fault relay, and this is again related to overcurrent protection scheme. Now we have not started yet differential protection. This is phase fault and earth fault relays. Okay, that is and phase fault and earth fault relay and directional relay. In seventh lecture we have seen, as I told in fifth lecture, for phase fault setting from 50% to 200% in steps of 25%. For earth fault it is 10 to 90% in steps of 10%. So how many phase fault relay and how many ground fault relays we require, this we have studied in this lecture. Okay. Plug setting, time dial setting. Okay, so we are using three is for one phase, one overcurrent relay and earth fault relay. Instead of three overcurrent and one earth fault, we are using two overcurrent and one earth fault relay. And this is our directional relay. In directional relay, in addition to the quantity which we are measuring is current. In directional relay, we are measuring another parameter, that is voltage. Okay, so we require two elements. This is called as directional element and this is called as non-directional element or overcurrent element. So where there is an importance, where there are double infeed system, where there are parallel feeders, where there are ring main system, there we are using directional relay. Okay, this we have studied in our seventh lecture. Okay, we have derived the relation also. Okay, now in our eighth lecture, this we have applied current graded scheme and time graded scheme. We applied to the equipment, that is feeder protection with directional time and current grading. This protection we have applied to the feeder. Okay, parallel feeder we have applied time graded and current graded scheme. Then lead feeder, then for ring mains. Okay, the same problem you have solved in your CT1. Okay, this is for feeder protection. This is our 8th lecture. Now Do you have any doubt up till this 8th lecture? If anyone have any doubt, they can ask. Write in chat box. Up till 8th lecture, do you have any doubt? This is about overcurrent protection scheme, classification of relay, different parameters of relay, requirements of relay, evaluation of relay. Do you have any doubt? Write in chat box. Write in chat box. Do you have any doubt? Sure replied. Sure replied. Then Ashish, Sanket, Somnath, Himanshu, Priya, Nikhil, Ankush, Sneha. Okay. Kunal, Karthik, Yash, Gauri, Ankita, Milan, Rahul, Priyanka, Aradhya. So, I can assume that, Swati, I can assume that you have no doubt up till this lecture. Okay. Now, in 9th lecture, in ma'am, batch 1 have, okay. Okay, before that, batch 1 have LDIC lab at 11:40, na? So, wait for 5 to 10 minutes. Wait for 5 to 10 minutes. I will cover up because only 10 lectures are remaining. Only 10 lectures are remaining. Wait for 5 to 10 minutes. Wait for 5 to 10 minutes. Okay. I will cover up speedily. Okay. Now in 9th lecture, we have covered differential protection. We have covered differential protection. In differential protection, current balance principle and voltage balance principle. Okay. This differential protection is applicable to generator, transformer, motor, buses, lines and feeder, reactors and capacitors. Okay. So this we have covered in our 9th lecture. Okay. Now in 10th lecture, some advanced, because this differential protection have certain drawbacks because we are using two CTs at both ends. Two CTs at both ends, so we have to minimize, we have to improve that operation of differential relay. Okay, so because there is a CT mismatch, we have to minimize the spill current in the relay operating coil. So we are using differential or percentage differential relay. Okay, that we have studied in our 10th lecture. What is the limitation and how we can overcome the problem, that we have studied in our 10th lecture, that is differential protection. Okay, percentage differential protection or bias differential protection, that we have studied in our 10th lecture. Okay. Now, listen, shall we stop or shall we continue? Right? From 11 to 20 lecture, shall we stop or shall we continue? Reply in chat box. From lecture 11 to 20, shall we stop or shall we continue? Reply in chat box. Okay. Abid. Acha, till CT1 all clear. Okay. Sanket. Okay. So I think you have no doubt. Okay. Okay. Sanket, Ashish, Abid. ठीक है. Tomorrow we'll cover. Oh. Ashish, what you want? It is clear, na? Ashish, it is clear, na? Acha, after CT1. Okay, that I will cover, na? But up till now, whether you got this or not, I will cover that part also. I will revise that also. Okay? So, No, I will stop here. I will stop here. Okay. Tomorrow at same time we'll meet. Okay, 10:45, 10:30, 10:30 to 10:45 because again I got late 5 minutes. Okay. So tomorrow at same time we'll meet. Tomorrow is Sunday, na? No, on Monday. On Monday we'll meet. Okay? Okay? Okay. Namrata. Puna.